All right, this problem should be fun to examine because it's probably something that you're not too familiar with or hasn't come up very often. So let's go ahead and take a look and see what kind of function this is. It is a piecewise function, so we're gonna need the y-axis and then only the x-axis. And it's important to see the distance between these endpoints in each of the domain parts. So they're all 1 unit long, so it makes sense to make tick marks that are 1 unit long as well to help us examine what's happening. And so in a minute here, we'll take a look and just examine each piece one at a time. So let's go ahead and take a look at this and notice that between -2 and -1, and it's probably important to note that this is a less than or equal to symbol. So we're looking at this interval here. The output of the function is -1. So let's try to see if I can make that look accurate. It's not perfectly flat, but it's flat enough. And then, of course, at -1, we're going to draw a closed circle. That's not as important for what we're doing right now, but it's still worth doing that correctly. In fact, all of these are going to be that way. So the next one goes from -1 to 0, and it's 0. So that's going to be, and I'm just for emphasis, I'm going to do it just a little bit above, just for emphasis. And let me see if I can make that really wide, just so that we could see that, yeah, that's where it is. And I'm going to make that. And so that's what we're essentially working with. Each of these goes up 1 unit, and it's a flat piece. So this is basically called a step function. And that's what we're making here. We're making a step function. So between 1 and 2, the function is at 2. So something like this. And that might be as far as we need to go, even though there's more in there, because what are we interested in? We're interested as in the curve as x approaches 1, +1 from the left. So our focus is somewhere, somewhere in this area, because this is where x equals 1 is. And so if we're going to approach from the left, we need this piece here. And so for part A, then we're looking at the limit of f of x as x approaches 1 from the left. So it's going to be f of 1. Since we're approaching from the left, we have to look at the appropriate part. Maybe I can highlight it blue just to help us remember which one we're looking at. And so the output is a 1. Okay, now if I do part B and say, okay, now I want the limit of f of x as x approaches 1 from the right, I need to evaluate the function at 1. But the appropriate part to use would be, let's go maroon, be the maroon piece. And the function evaluates at 2. So those are different. This is a 1, and this is a 2, and they don't ask this question But if we just plainly wanted to know the limit of the function at as x approaches 1, we would have to say that it does not exist. They're not asking us to go that far, but indeed the left and the right limit are not the same.